Hi. Howdy, folks. So before we start, I know David asked a little bit, but I kind of want to know because I am naming my talk how to migrate from Nest to Effects because I love Nest and I've used it for many, many years, but that is not necessarily the reality for everybody. So give me a show of hands. Have you used Effect on something real? Or maybe looked at it? Okay, good. Not at all. They're just here for the vibes. Right on. How about Nest? And when I say Nest, something similar to Nest, right? Like Spring Traces or .NET or anything that is decorator-based, aspect-oriented programming, that type of stuff. Anybody who's shipped any of that in production? Okay, a little bit more people. Right? So you understand how those frameworks work, right? You have your classes that have methods that have behaviors in them, and then you add decorators and some dependency injection container orchestrates that thing, and request comes in, something gets resolved, and gets run, right? Good. And then really hard to if you don't know what these are, this talk is not going to be helpful to you, but I still want to know who has not done something in production that was solid patterns, domain-driven design, dependency injection, inversion of control, like these enterprise C patterns. Yeah, cool. All right, so I have been using Nest for I don't know 10, 11 years. Love it. I have a bunch of apps in production that run in Nest. And I actually just gave a talk about not chasing shiny things and not fixing something that is not broken. That was in React Miami just in April. And the talk's over there. And we'll share the screenshot, the video if you want to check it out later. But the idea is, hey, I come from a place where stuff breaks and it doesn't matter. It has to keep working. And you rarely just make one big architecture decision. Like you make changes as you go and then things compound and you have a layer cake of decisions and things need to keep working. You don't throw away the learnings. And now I'm telling you, yeah, you really should go to Effects when I was saying this like a couple months ago. And here's why. So that guidance is not about never ever migrate, never ever look at new things. It's, hey, there's a high bar for a new tool that a new tool has to cross. For me to decide, there's something here. Let me take a look. And that bar is, hey, it really needs to be fixing something that is big pain. It's like you wouldn't just go to a conference talk and somebody's talking about something really cool and then you say, oh yeah, I'm gonna go with that. No, it really should do something meaningful for you. I believe we should all be picking abstractions that put you in control. It shouldn't force you to rewrite things. You can rewrite things if you want, and I'll show you a repo that I built that is from scratch. But it should be possible to incrementally adopt things and incrementally migrate into the new thing. And then I want to see something having been shipped. And so to me, the facts, being on V4 beta production release imminent, clears these things. So again, here's two repos that both are mine. That's my, I don't know if you are going to be able to see this. That's my GitHub. And so Zero Sources is a change source, a change data capture implementation for MongoDB for Zero Sync. If you're not familiar, I invite you to look at it. It's really, really cool technology. And on the right-hand side, cBranch is, I am migrating my work from Windows to an Ubuntu server, and I'm losing my preferred Git GUI editor. And I was like, you know what? I'm gonna build one that has the same user experience, and I'm gonna build it in Effect. So I'm going to show you things on on each side of the screen. So you see, how do we deal with these things that, Nest doesn't do really well today? So for example, you have a application service. That application service injects 3 repositories, and then you make some calls, and maybe one of them, the repositories are talking to Postgres or MongoDB, and you have network partition. Or you have a database that is overloaded, and you get timeouts. And sometimes you get timeouts, but not always you get timeouts. Fantastic. You now need try-catch, and your application service controller, unless you're doing errors as types or errors as values, most of us, if you're using Nest, are not going to be doing that. So there's no static analysis for what the error type or the type of the error is that your application might throw. In Java, Java forces you to declare exceptions. In TypeScript, that doesn't exist. So that is one thing that I've never liked about Nest. In TypeScript, specifically in Nest, you might have a class decorator that has a DTO with some annotations, and then you might have some code that checks for things imperatively. And yeah, I'll keep going. So I'll give you one very concrete example. This is an observable, which is very native to Nest. And this is how I start watching for changes in the MongoDB collection. Like I mentioned, Zero Sources is a change data capture application. And so first off, I actually have to go over there. Start watching a database connection, and then attach events on it, and then handle close and handle error. Without looking at the right-hand side, don't look here. Who can tell me what's wrong with that? I'll give you, I don't know, like a couple of seconds. Don't have to be too intense. I'm handling a change event of an observable, which is an event emitter. And you can see here, this is an async function, right? And then I am iterating a function that returns on a sequence of items. And I'm not awaiting it. There's no for await here. Like this broke badly. And I could have avoided this. In fact, would have helped me avoid this. Additionally, look over here. This one, this error variable. What type is that? Whatever the mongoose driver is gonna throw. I mean, right? So, like, if you give this to an agent, it's not gonna have grounding information to even code defensively. And like, I missed it. I've been a software engineer for 20 years. I've fixed things like this all the time. I missed it, like totally missed it. So yeah, the new guy comes in the team, joins the team. Yeah, we're TypeScript, we have types everywhere, so it's really easy. Yeah, and your errors, right? So no, yeah, most of us have no typing for errors because the language does not force us. And yeah, we never do it. So this is difference number 1. Effects. I like this. I struggle with this, but effect forces you to declare your stuff up front so that you know that if it passes TSC, like the TypeScript compiler, most likely it is correct. Even if it's not what you wanted it to do, you still might have logic errors, but you almost never will have syntax errors. And I don't want to say never, never, but pretty high confidence there. And how does that, oh, hold on. Yes, I'll get to the effect. Or I guess you'll show the result of the effect that's a result of the error signature later, right? The result of the error signature in effects. Yeah. Okay. So I'll let Ariel show you the signature, how it actually happens, and I'm gonna focus on how do you go from nest or nest adjacent or nest equivalent to effect. Well, the good news is all the things that you're used to when you're using these frameworks have somewhere to land in effect. So we talked about an application service, and you would typically have those decorated with this injectable decorator. You have your class, you decorate it with that, and then you provide that class to your provider, right? So in effect, you say, hey, context plus stack, and you make a service interface. And then you provide it in a layer, right? A module, which is where you provide your, I keep pointing here, and I just, let me do something. Because I keep wanting to point here and not realizing that you guys can't see what I'm pointing at. There we go. Yes, keep changing this. There we go. Display settings. There we go. And there we go. All right, so a module, which is where you provide your services. Well, in effect, that's a layer. And you can compose layers. You can take a layer and provide it or import it into another layer, just like you take a NestJS module and you import it into another module. By the way, this is the same way that it works in Angular. It's a very similar way as it works in any other inversion of control, dependency injection container framework. You take your container, you provide some services in there, you have a reference to that container, and then you pass it around and you resolve stuff when you need it. And then you can compose, right? You can have a container that then gets provided to another container, and then it can use that to like hop to the next layer, the next context to get stuff. In Nest, you can do field injection. So you can have a class field and have a decorator on it, and then the framework magically gives you an instance, or you can declare a constructor parameter, and then the framework gives you that instance magically. In effect, it's actually more simple. Inside layer and effects, you just say yield the provider token, and you get the framework magically gives you an instance. And Nest, you throw exceptions, and then you either have catch decorators or you have validation pipes, the output pipes that catch errors across stack traces or across asynchronous stacks. In effect, this is, well, I'll let you go a little bit deeper here, but in effect, you declare your services as effects, returning type A, or potentially throwing error E. And this is what I was mentioning before, right? If you know that you have a specific error type that your code might throw, or you know that your dependency might throw, or you're talking to the file system, or you're talking to the network, you put the union of all your errors in here. And that lets TypeScript know, and it lets the agent know, and it lets the linker know that these things might throw, or this code might throw these errors, so you must handle them. Or, the whole thing crashes, right? So more simpler, instead of like multiple ways of doing it, you just declare and then catch. In NestJS, you can do some initialization code and some cleanup code. And to do that, you implement onModule init and onModule destroy on your modules or your services and stuff like that. In effect, same thing. I'm not going to go into this in too much detail because I still need to figure out how this works at scale. But there is a way to do it. Scopes and releasing resources. And then finally, in Nest is a Node.js framework. And this is one of the biggest reasons why I even decided to take a look at effect is I have a lot of stuff that runs on Cloudflare. Nest cannot run on Cloudflare without being super wasteful. And I actually ran NestJS in Lambda in 2017, 2018, and that was painful. So Nest in production, as Camille, the author, intended, requires a long running process. If you're embracing serverless and Cloudflare and stuff like that, Nest is not great. And I wanted that flexibility. Effects doesn't care. You can throw it anywhere. One of the repo on the right that I told you about, and I'll show you again in a bit, does not. It by default runs on Node with no runtime or effects adapter for Node, but you can also launch it in Cloudflare or in Vercel, and all the places. So mine does this today, but there's many adapters. So we'll share I'll share the slideshow, and you guys can take this as a reference. So like what I was saying, right? Module, and then you provide, and then some things can actually be consumed outside of this module, wherever you're inputting it elsewhere. Layer, merge, all of these things. How do you provide a service? Well, in Nest, you make a class, you make it injectable, you inject some things into the constructor. In effect, you make a class, you make it affect a service, you make it extend the service class, and then you provide it with a layer. Your global module, you initialize a Nest factory that create iNest application is what this thing is, and then you run listen, or you run connect microservices. In effect, you make a layer, you make a program, which is a generator. I probably should talk about generators here. And then you run it with an adapter. So let's talk a little bit about this thing. How many of you guys are not familiar with generators in general, in like engineering or in JavaScript? So you guys were, okay. Like, show me your hand if you know how generators work in JavaScript. No? Okay, a few people know. Great. We should talk about that. So the generator, it's a design pattern in software engineering that changes the order of control, or which part of the program controls execution. When you have a method that returns a generator, which is what this star thing next to the function means, what that does to the runtime is it allows you to pause execution here until the calling code calls await again. Or for await, or iterates await. So in C# and in .NET, you just do async and yield things. You don't have the star. In Java, it's not future, but there's like a specific class that you implement. In JavaScript, that's good. You say this. When you do that, that is built into ES6. And what that does is, instead of your function returning a promise, it returns a generator. And if you've seen observables or something like that, or streams, or event emitters, it's very similar to any of those, where if you take an enumerable thing, for example, an array, a list, a dictionary, something like that, you control when you get the next item, because you call, give me the next item. With a generator, the code that's inside controls when the next item is produced. Does that help a little bit? Okay. Definitely recommend check out generators in the TypeScript documentation. They have really good documentation and interactive examples. In effect, everything is a freaking generator. Like, and I mean everything, including, I don't know if I have a showing you before. Well, we might have somewhere something that shows you that, but including dependency injection, I know that I showed it. There we go. Dependency injection. This, resolving a service. You yield start the injection token. And that tells the runtime, hey, inject an instance here. So even dependency injection is consuming a generator. Okay? And it is like that because when you implement your service, which is over here, right? You're actually extending something that affects the framework the library gives you. And this thing internally is a generator. Okay, so app module and handling errors. Effect catch that. This is where it is significantly different. So you have an effect, or effect wants you to have named errors, which is like in Java, for example. In Java, you say this function throws IO exception and HTTP exception, like my custom domain model error exception when the user is not authorized, whatever, right? Effect wants you to declare that, and this is how you do it. And then you do exhaustive. Exhaustive here meaning because you make error types that each have a specific meaning, then the LSP and the TypeScript compiler can actually keep track of all the exceptions that your code might throw that you have not handled. And so if you notice here, I have a tagged error class of the same thing. And yes, it is weird. It is using the type in its type. Don't worry about it. But then you're tagging it. And then this tag get error is then what you use to tell effects, hey, when an error that matches this tag occurs, this is how we do it. This is how we handle it. Okay. So in Nest, you would do this with output filters or pipes, and you would have one pipe after the other, and you were composed by stacking pipes one on top of the other, or exception filters one on top of the other. And here you do by attaching catch. This is the real, like these two things, the generator versus the observable, and the error type being explicit are a big deal because it means that you have a way to do static analysis when you're building your application and not wait so it breaks in runtime like it happened with my change data capture table. And then of course, yeah, you have other things that Effect gives you as well. In Nest, you have class validator, and now Nest 12 is adding SOD. A little bit too late, if you ask me. Fastify has had that for a long time. Effect has a first party schema management solution. It's called Effect Schema. And Effect Schema lets you do parsing, validation, and serialization, input and output. So really complete solution. So what you used to do with isString and API property and is optional, and then validate, nested, and all that in Nest, you used to do with the schema. Is the Effect Schema standard schema compliant? Okay, and it is standard schema compliant. So you can use Effect Schema wherever a SOD schema, a volleyball schema, or an archetype schema would have been expected. So it's also got that going for it. Oh, and then like real world scenarios, right? You might want to do consumable promises. You might want to do concurrency, or you want to do synchronization between different processes that are happening, or you might want to do queues and retries, queues and dead letter queues and retries for asynchronous jobs. It's like in Nest and in Node.js in general, you have a soup of npm packages that you install. and then you compose them yourself. The effect gives you a coherent story where you have this fluent interface and piping of generators one on top of the other that has all of this built in. Now, of course, I can't just come here and say, hey, you should just throw away what you have and you should go to effect right now. I'm not asking you to. What I am saying is you can take effect and apply it to a slice of your Nest application or your existing application. So say you take a module or take a service inside of that module. So in my case, I have this thing that connects to a MongoDB, watches for changes coming from it, keeps a track in a KV store, a SQLi. And so how would I change? How would I migrate that? I'll probably start by defining a structure for the data that I care about. So like tenant ID, I won't bore you with the details here. On the left-hand side, it's an excerpt of what keeping track of what's the last event that we saw from the database looks like in Nest. Preparing a database query, comparing, did we get is the value that we're trying to keep track of greater than the last one that we saw? Or is it the same? If it's greater, then fantastic. This is now the latest one, send it to the database. If it's the same one, somebody beat us to it. So we have to go back and try it. In effect, put with reverse, like a key value thing in Nets. And we either, we yield it, and if it fails, that means that this is gonna run as a transaction. It's failed the transaction and try again. Most importantly, you would, at the same time that you can do this, so get the increment the watermark and try to put it in the database. If it doesn't succeed, return it and then retry. So, and this is really the unlock. So if you have a Nest application, if you have something else like a type DI application or something where you're a guest in the runtime and you want to bring effect, then here's a pattern that you can use. You make an effect managed runtime with your, all of your provided things, your dependency injections. When a request comes in, so where's program? I guess program is through the function. So if you have existing, okay, I might have botched this slide, but let's say you have existing logic that's represented by this program. You make an effect, this run effect, that calls, hey, this managed runtime with all of these services provided to it, you're gonna run this promise. And here program is supposed to be a function that returns a promise that maybe uses other code in your application that you don't wanna touch yet, right? And on request, this.effect.run. And this would be, this handle connection is a method in the change data capture gateway, which is a WebSocket gateway. This runs when a new client connects to the WebSocket gateway and starts streaming changes. So like this is me applying this logic there. This.effect would be the effect runtime.run, which is this method, which is wrapping my my program execution into an effect runtime. Right? So I'm gonna skip here because we're going super long. Some things to keep in mind. Effect likes to expand. This is gonna sound funny because people usually say this and they don't mean it seriously, but I'm gonna say it very seriously. It insists upon itself. And if you, okay, nobody got that joke. Good. You want to be conscious where you got it with something like this, for example, because just like when you have a function that returns a promise, everything else needs to accept a promise or do async await. Generators are the same way. So if you have something that returns a generator, it's going to take some handling so that you can adapt it to the shape of the rest of your application. Effect has utilities for that. So not a deal breaker, just you know that the boundary takes special handling. The try promise and like all of these other like adapters is where you are gonna pay some performance tax as you have things that live in both sides. But it's okay to pay that tax. You should not rush into it. But just know that. Effect v4 is in beta right now. I'm building with it. OpenCode is built in it. By the time you actually get something in production, or you get your team lead or CTO to let you play with effect in something real, or if you are the team lead or the CTO, you let yourself play with effect in something real, and it's gonna be general availability. So like start with v4 is a lot more lightweight. It's a lot more better built than v3. And then, yeah, Claude, do me a 30 here. Just generators, variants by like this concepts up here. Just pay attention to it. Right? When is it not a good fit? If you just have a CRUD over Mongoose or Postgres, you have REST API, it's like a very like minimal application, yeah, maybe stay where you are, right? If your team is not super strong with TypeScript, maybe stay where you are. If the module you're gonna be touching or the thing you're gonna be migrating was built by the guy that left 5 years ago and nobody knows how it works, maybe leave it alone and start with something else. And then if you don't know what your failure modes are, probably work on that first. For all others, yeah, effect is for you. Takeaways for you. For most of the things that any framework that you might be using in TypeScript does, certainly for Nest, there's a one-to-one. Like the things you're used to doing, there's somewhere that they land in effect. You're gonna get more resilient, more trustworthy code. Your agent's gonna know what the heck it's doing because it's gonna know what errors it can expect. And then you get consider schema compliant things so you can interrupt with other things. Start slow and just go step by step, validate along the way, and expand. This is me. If you want to stay connected, my socials, specifically GitHub here. The two repos that I showed you are both MIT and available on my GitHub. The C branch one, the Git GUI, is still a work in progress. It's all over the place, but it's a good place to follow along the way that I built something from scratch, like I've been building over the last 3 weeks with Effect 4. And some decisions in there. Oh, and by the way, I didn't write it. I prompted it, and it's like big. So I'm pretty satisfied with the work that the agents have done with it. And then on my homepage, I have this page about Miami and my vision for Miami as a technology hub. I invite you to take a look at it. And if you want to stick around, we're going to be hacking on effects a block from here till midnight tonight after we're done here. Thank you.